So this talk is not a single research project, or probably for some of you it might not even be considered research, but it draws together a bunch of different theoretical work from around the world, as well as 3 particular case studies that I've been intimately involved in over the last decade, basically. The first one from my PhD, looking at climate variability in the rangelands and how graziers make decisions about climate variability and how scientists try and make climate information useful to farmers and graziers. And the other 2 cases are from more local context of sea level rise planning in the Clarence and Kingborough councils, and also from salmon aquaculture and how science is used in environmental management in salmon aquaculture. So they're very different contexts, and I'm sort of interested in how extension applies to those different cases and what we can learn about the scaling of extension. Some of you, for those of you who have to leave early, Kathy, I'm hopefully going to finish in 30 minutes or so, but I haven't actually timed this. But really, I just want to give you the take-home messages so you can take them home if you need to leave early. But I think extension can enable change informed by science. So extension is often talked about as enabling change. What I'm particularly interested in is how science and extension and change work together. The second point is that scaling extension requires linking science with the values of stakeholders. And this is often an uncomfortable thing for scientists because it's getting into a political and messy space. So I'll talk a bit more about that as we proceed. The third point is that risk and uncertainty, which are often very difficult things to operate with for decision makers of various ilks, extension can make those things actually useful and usable. So I'll talk about how that might happen and how it happens in different contexts as well. But first of all, extension itself, there's a lot of different definitions of extension, and we often think of it as a mechanism for getting science out there. But really, it's evolved a lot from that in the last couple of decades. As extension funds have decreased, it's been seen more of a way of creating and enabling change in individuals, communities, and industries involved with both primary industries and natural resource management broadly. So not just within agriculture, but within fishery sectors, within mining, and broadly within the whole context of natural resource management. So that spans all sorts of land management, coastal zone management, and ocean management. So there's all sorts of trends, some of which I'll talk about today, which are making it clear that extension is integral to our ability to manage our natural resource base and use our science effectively. So the CELN, State Extension Leaders Network, which is an interesting and very small organisation, gives us this definition. And they also point out that it's a policy instrument to be used with other policy instruments. It's something that doesn't work very well by itself. It needs the research and development. It needs other regulatory and other instruments to be in place for it to work effectively often. It's a way of building capacity, and that's not just capacity within the community, it's capacity within research institutions as well, because it enables research institutions to be grounded in local contexts. And it's a field that uses very diverse methods, from this sort of thing where someone stands up and talks to much more engaged problem-solving, participatory and collaborative processes. So I probably won't talk that much about the methods of extension today, but these are just things to be aware of. What I really want to focus on is how it can bring scientific knowledge into societal decision-making about primary industry and NRM. So really that focus on the interactions between science and the public discussion or the private discussions about what we do and why we do them. This is a bit of a messy picture, but I'm going to run you through it. There's been a lot of change in extension funding over the last 30 years. In Australia, as in many developing countries, we used to fund public extension to achieve a private benefit, so to achieve benefits for private landholders in pushing out agricultural technology and research into the community. We don't do that so much anymore. So there's been a huge decline in public funding for extension, and it's more considered to be the sort of thing when there's a really good public benefit, as in improved soil or water management, weed problems, the sorts of things that are in the NRM space, is where we tend to fund extension. So there may be a private benefit, but usually the main focus is on a public benefit when it comes to publicly funded extension. Where there's a private value, we tend to fund the research and development to produce knowledge, and the assumption is that the private manager, land manager or farmer will see the value in it and utilise it in an appropriate way to gain their value from it. The questions around what the societal values are have shifted in this way. This is actually a large-scale societal shift in the way we think about what are the appropriate policy instruments. So where there is a negative private value but a positive public value, we tend to think the sort of incentives are the way to go. We pay people to covenant land, for instance, recognising that there's a public benefit but they're going to lose something. And then in this space down the bottom here where there's less private benefit than there is public benefit and negative public benefit, we tend to regulate. So this is around environmental management. We prevent people from spilling their toxic waste into the environment through regulation, etc. And similarly, where there's no private or public benefit, we regulate slightly as well, but there tends to be pretty much a policy vacuum. The assumption is that we won't do those things that are not in a private benefit or a public benefit. I'll come to, the three cases, I guess, are that I want to talk about today are one in the rangelands, which is very much that public good, private good sort of situation, where managing climate variability creates a public benefit through loss of reducing degradation of rangelands, and a private benefit through allowing people to maintain better quality land and produce better stock and therefore create ongoing profits. Salmon aquaculture, we've got a public waterway which is used for a private good essentially through lease arrangements. So there's potential environmental consequences. Well, there are environmental consequences. And how we trade those off is usually considered to be a regulatory issue. I'm going to talk about it in terms of extension. And planning for sea level rise in a council context is where we have environmental change caused by storm surges and gradual events associated with climate change, which create both public and private bads, as it were. So that's the sort of context in which we're working. I'm going to suggest to you through this that extension has its place across all these quarters of the picture. But I want to just quickly talk about risk and uncertainty. This will be familiar to some of you as the known unknowns and the known knowns and the unknown unknowns, which Donald Rumsfeld made famous in a media interview several years ago in relation to the Iraq War. The known knowns we associate with risk, and these are the things that we can manage. The known unknowns are more complicated. There's the uncertainty, the stochastic processes which create chaos, and we don't know exactly what's going on. And some of that uncertainty is non-reducible. There's indeterminacy there. We cannot know because the processes themselves are stochastic. And there's also often ambiguity there, and by that I mean that it's not quite sure we're certain what the drivers or the problem are, or those sorts of things, which I'll get to in a moment. And then there's the unknown unknowns, the ignorance part of the spectrum, which is simply we don't know what we don't know. We don't know what we're looking for. So we often talk about risk and uncertainty very simply. There's a whole huge literature around these things which is fascinating I've also put the unknown knowns in here, which are the secrets, and a large proportion of the world's R&D is secret in that it happens in the military-industrial complex, and no one ever finds out about it. And other confidential commercial spaces. So there's a lot of research and development which is unknown knowns. And also, to give you a bit more context, I just want to talk about complexity. So we talked about risk and uncertainty just now. Complexity of systems is another thing that's a critical component when thinking about environmental management, because we often try and manage problems as if they were simple. There's an old adage, which is now old: for every complex problem there's a simple solution, and it's always wrong. And this is because socio-technical systems, these level 2 sorts of problems, have a central core, perhaps. Say soil management, we understand things about soils, but they interact with human activities, and we don't know necessarily what those interactions with human activities are driven by, whether they're driven by incentives in the market or in policy settings. So we have emergent phenomena in these socio-technical systems where the interaction between the biophysical and the social collides and creates unforeseen events. These things become even more complicated in a highly networked global society where the emergent phenomena, if you want, from these more simple socio-technical interactions explode into much more complex emergent phenomena, such as the global financial crisis and things like that, where we cannot predict necessarily. I mean, there's probably enough of us that we can predict just about everything now, but there's no necessary experts around these really complex levels of interaction. So I'm sorry to burden you with the theory at the beginning, but just one more, if you'll allow me, is around problem structure. So that level of system complexity is one thing, but we also have to look at problems in terms of the political situation and the stakes involved in them. So once again, we often think of problems in a somewhat simple way as well-structured problems, and many problems are well-structured, and we can resolve them through simple application of technology or systematic processes. So well-structured problems where we have converging values and low stakes are amenable, and all low stakes are amenable to this direct application of technical information. The example I've got there is Cyclone Yasi. When a cyclone is approaching the coast of Queensland, everyone agrees that we need to do particular things to protect life and property. And so no one really argues with the science. There's no point in arguing with the science in these well-structured problems. We can come to a conclusion pretty quickly that we all agree on, by and large. A moderately structured problem, so I'm just sort of using weather, climate examples here. We understand that there's enormous climate variability in Australia, and we need to secure water resources for our growing cities. The outcome here is these desalination plants in Sydney and Melbourne. So we've managed to create a majority opinion, or at least a form of a politically acceptable outcome, which is that we're going to build these things to deal with what is quite a complicated problem, but we can reach majority understanding about it. More poorly structured problems are things like drought policy, where we might agree at one moment that we all, or farmers, land managers, need to prepare themselves for inevitable climate variability. They need to know that a drought is going to come back. Droughts are normal parts of the Australian environment. But when the drought does come back, we don't agree on what the policy should be. We don't agree that people should have prepared, because we get things like pictures of young girls looking sad on the front pages of newspapers, and people saying that we need to step in and look after the farmer and the land. So the agrarian sentiment in Australia is a very strong thing that drives the politics of these sorts of problems. So poorly structured problems are things where we don't necessarily all agree, and there's trade-offs between winners and losers. So divergent values end up winning the day. Really unstructured problems are things like climate change, where we don't agree on what we're talking about at all. So I might be talking about whether the evidence of climate change is strong enough to suggest that the signal of climate change is caused by anthropogenic greenhouse gas forcing. That might be what I'm talking about, but you're talking about whether we need to change our whole political economy to a renewable fuels base. So there's all these conversations that are going on and no one is necessarily talking to each other. So a current one in Tasmania is GMOs. This is a classic example of an unstructured problem where some people are talking about science, some people are talking about markets, some people are talking about protecting an image. There's all these conversations going on and no one has really structured the conversation. So that's just a bit of a background about the different sorts of problems that extension contributes to, and partly by enabling people to talk about different things at different times. One of the ways that I think we've come to through various literatures that have been pulled together in this particular article, which I recommend, is an understanding that we need to talk about the relevance of our science at the same time as we're talking about how robust it is, how credible it is methodologically, which we tend to be concerned about as scientists, and also the processes that we use to make it legitimate, to make the knowledge production legitimate. So these three components interact. If I could tell you what the weather's going to be like tomorrow, I could say it's going to be a beautiful day tomorrow, and that might make you very happy because it's very relevant to your weekend plans, but I have no credibility. I'm not a climate scientist or a meteorologist. So it's a relevant piece of information, but it's not credible. So that's just an example of those sorts of trade-offs. So I'm sorry I've loaded you up with all this theory at the beginning, but now I'm going to talk about some particular cases in which I think these different components come into play. But I just want to talk for a moment. I'm a social researcher, and many of you are not. So this research is based on qualitative social research, which really asks these questions about how things happen. How do we think about problems in society? How do different people constitute the problem? And how do they make decisions? These are the sort of questions that are interpretive. We can't pin down very precise and mathematical ways for investigating this. And if we could, we would get answers which were meaningless anyway. So the sorts of things we look at in this sort of research are the ways people talk about things. So these scripts which indicate things about people's identity. Farmers are the original environmentalists. These are actual real quotes from my PhD. They're things where people are expressing something about their identity, and they tell us something. We can pick these up and put them all together and get a broad picture of how a group of people identify themselves with the environment or with particular outcomes. And similarly, parables are an example of a sort of cautionary tale, a way of warning you about something that you shouldn't be doing, what you should be doing, telling you what you should be doing by telling you what you shouldn't do. So it's better to sell them than smell them. Is that obvious to everyone? In the context of a grazier in Western Queensland, you make a decision to sell, and to sell early, in order to avoid the market collapsing and having to sell weak, poor stock into a low market. And then you have to smell them because they start dying around you, right? So it's an example of how someone can very quickly, in a few words, tell you about their strategy in some ways. Of course, you triangulate this against other things, so I won't go into that. This case from my PhD is about the rangelands. And these three areas in the rangelands around Longreach, the border area, and Hillston in the south, west of Hillston. I did 70 interviews with graziers in those different areas, but I also interviewed 35 climate scientists and applications researchers about how they try and make their climate information useful. And that's really what I want to focus on today, that little bit. So they're talking about ENSO, El Niño Southern Oscillation, and impacts that ENSO has on this Australian rainfall. So El Niño years are very much drier than La Niña years on average. doesn't mean they always are. And Rowan and others have talked about this. Holger led a lot of this work in the early years, and those two have done some amazing innovations in this space. So you probably heard about it all from them. What I want to talk about is these, what I would say are 3 different modes of extension that evolved through that climate applications work. So these guys who are climate application scientists took agricultural systems models, pasture growth models, and integrated them with climate models and tried to create outputs which were useful to people on the land, to decision makers on the land. And to do this, they worked very closely with some farmers and graziers to try and ground their models in the particular locations that they were operating. But they also ran around the country doing all these workshops, basically trying to build an interest in the science and trying to understand how people could use the science. This is what I'm calling conceptual extension, because it's about the concept. It's not about how you actually use it in a particular location. It's the idea that what happens in the Pacific Ocean has some bearing on what happens on your property. So the way they did this through their stories was of their actions and interactions was to understand that what was important to people on the land was the history of the locale, the locality. So they tapped into this idea that you need to make things real through history. You need to talk to people's own memories and their grandparents' memories of the place in order to tap into that. So they used pictures like this, which show the association between the Walker circulation, between the water temperature in the Pacific and how that changes, and the rainfall in Australia. And they showed how the SOI went up and down, and this is the sort of thing, I mean, it's a short time scale, it actually goes back to the 1880s, this record. So people could actually look at it and look through the history and make the association, oh, when the SOI was high in the 70s, that was a really wet time. Yeah, I remember that, and go further back into the 60s and 50s, and how my grandfather used to talk about the 40s drought, and that was an El Nino too. And so it started to become part of the local stories through this conceptual extension. That translated into things like maps, where people could actually start to see what the probability at a particular time of year was for rainfall at their place. Different maps from different agencies were sometimes confusing. But the whole picture is of associations, of history, and of stories that gel with what people experience on the land. The second form of extension was a much more grounded, precise, and what we might call decision support systems sort of extension, which used the systems models within particular places and relied on close discussions around what the assumptions were behind the models, how they related to my place exactly. So they required lots of measurements within particular locations, and researchers would sit around the table with farmers and graziers and talk about how that applied to them. So we're not so much here talking about extension agents going out and doing the work here. We're talking about researchers interacting in a participatory way to try and understand how their systems models do or don't work. But through that work, you could see that these systems researchers were also changing their own language and the way they thought about the problem and the way they expressed the problem. So they changed this decision support systems to discussion support systems to emphasise that it was about a dialogue. And through that dialogue, they started to talk about climate in a different way. So this is the third, and I think the sort of broadest level of climate communication, which is discursive communication. It's about creating a discourse of climate, the shape of the climate. So these are quotes from radio interviews with climate applications people. Dig down and survive another fairly dry period. Average conditions are not normal. Australia is naturally inclined to extremes. Most farmers in Queensland would be already preparing for the possibility of another El Nino. So this is sort of normalising the whole thing, that you do this sort of risk management as a matter of course. It's not reflecting an identity, but creating it. Like, this is what we do. We are good risk managers. And my favourite, it's not time to jump off the tank stand yet. So it's that particular quote, recognising the enormity of drought for rural people, that it is a life and death situation in some cases. Down the bottom here, we've got the sort of latest iteration of this extension, which I would advise everyone to look at with their kids, preferably the climate dogs on the DPI Victoria website. So what I'm saying is that climate science to systems modelers to extension to graziers is not how it worked at all in this setting. And neither was there gradual loops and feedbacks between these two. It wasn't this simple. Rather, there's interactions going both ways. So your climate scientists who are really effective at getting the story out there were talking to graziers, to extension people, to systems modelers, and trying to understand the whole picture. So this is a level 2, 3 sort of problem, and that's why they had to deal with it in that sort of way. Briefly, I guess the differences between these two things, these three different categories, is that, you know, with your discursive extension, you've got a huge number of people engaged, and it's at a very broad level. At the contextual end, it's incredibly technically complicated, and you're only engaging a very few people. But you need to have all those bits working together, it seems, to inform each other. So that's that case. The rest of the work I want to talk about, and it'll be much briefer because I've run out of time already, is a couple of cases from Tasmania. Now, this is work that's just finished with the Coastal Collaboration Cluster, and basically we did 10 case studies where we looked at how science is used in various coastal zone management problems in southeastern Tasmania and Western Victoria, so working with colleagues in Deakin University. So the first case is around the eastern shore area of Clarence and how they're managing sea level rise, and the second case in salmon aquaculture in the Huon and Channel areas. So how is coastal science made useful and usable? Really, I'm just going to give you a very quick sketch of these issues and how they operated. So Clarence had storm surge events happening in the 90s. And as soon as the Australian Greenhouse Office put out some money for climate adaptation, Clarence realised that they needed to get onto this as an early issue. They saw that sea level rise was a key concern for them. They have very soft coastlines and a lot of them in places where there's lots of people. So immediately there's politics, right? There's a political imperative for them to do something. And by doing it early, they also got some standing in the community. So being the first cab off the rank, if you want, being the early adopters, they were seen as innovators by the rest of the community, which made them push themselves further. They were also very fortunate in that they happened upon a particular consultant who had an enormous range of policy experience as well as scientific experience. And the first thing he did was a survey of the community to try and understand their values. So when the reports came in from the Water Resources Laboratory in Sydney, which were very technical and detailed, he could not only understand them, but he could translate them into a language which the community understood. The community were concerned, so they came to the meeting. So he was able to mediate between the complex technical, the community concerns, and the council needs in terms of their policy making. He, to me, sort of implies the classic very skillful extension person who is across many things and able to interpret and translate across those things. This didn't happen at all in Kingborough. Kingborough has much harder coastlines, and most of the population live behind a large island called Bruny Island, which you will all be familiar with, which softens the blow, if you want, of the storm surges that hit the southeast coast. So when Kingborough did the science and had community meetings, no one turned up. So this just sort of demonstrates that the politics is necessary, that the events themselves create the politics through interest and stake and value, and that is required to precipitate some action. You don't want too much of it, otherwise you can't decide what you're talking about. But it's a really interesting case of two places where the similar science was done, but in one case there was an incredible ability to do community participatory planning, and in the other there's lots of science documents sitting on the shelf waiting for an event, as the manager there says. The second case is quite complicated, and I won't go into all the details, but salmon aquaculture in Tassie started in 1986 out of the government research laboratories. So a lot of people who were public servants started small salmon aquaculture companies, 13 of them initially, and they produced about 55 tonnes in the first year in 1986. Now they produce 40,000 tonnes, and there's 3 companies working in southeastern Tasmania. There are a lot of contentious issues around salmon aquaculture, and a lot of them stem from a legacy in which it was a growth industry in which the government pulled out many stops to enable its expansion. Now, there are reports often about how clean and green is salmon aquaculture. So this one was sparked by David Suzuki coming down and saying salmon is a terrible thing that you shouldn't eat because it's full of toxic chemicals and such like, and created a huge stir. Meanwhile, the companies have grown to a size that the largest one is a publicly listed company, and so it has to do triple bottom line sustainability reporting. But they've also learnt lessons from around the world, and they understand that in order to operate effectively, you need to have social licence. Tasmania is the only place in the world where we grow salmon in a very populated area of a coast. So they've also seen what can happen if you don't get social licence, and there's strong environmental NGOs. Now this gets to the crux of the story, because effectively we have a regulatory system for salmon aquaculture, but it is increasingly being superimposed, perhaps even superseded, by a market-based, community-driven regulatory system. So environmental NGOs, and in fact any member of the community, now has the ability through internet to run market campaigns which can substantially undermine a brand of an industry like this. And the industry know it all too well. But the way they do that is through what the industry would call misinformation. So this brings into question how we actually incorporate science into a complex picture where we have groups who are active and concerned about an issue, but don't necessarily believe the science because they think it's owned by the industry and by the government, who have traditionally been secretive. So we've got an emerging situation where there's intermediaries, if you want, who can stand between the government and the industry, who can do the reporting and the environmental reporting credibly. But this is effectively a role of extension. They have to understand what people want to know about. They have to understand what the science is, but they have to understand how to interpret it so that it meets the needs of different groups. So where, until very recently, we had a sort of simple regulatory setup, the emergence, if you want, of this level 2, 3 problem where we don't exactly know what we're talking about and it's not very well structured, we're starting to get a picture that what we need is an organisation which is arm's length from government, at arm's length from industry, and at arm's length from the NGOs, but has buy-in from all of them, that can represent the environmental impacts of salmon aquaculture credibly and legitimately, and in a way that's relevant. So I find this fascinating because this sort of thing I think is going to happen more and more as we gain more and more access to fast internet speeds, etc. And people gain greater awareness or have more awareness of what they're eating and where it comes from, and all that sort of stuff that seems to be part of Tasmania building its brand. The role of science in those sorts of situations has traditionally been very linear, directed at regulatory mechanisms. It's increasingly directed at broad community capacity, civic understanding of the issues. And this is, I would argue, a role for extension. So here's just a couple of quotes, one from an industry member. As the industry matures, you get to a point where you realise, well, we exist because we lease. We are leasing public property, and you don't get that if you don't have social licence. And from a person from the community, which broadly includes other bodies, other industry, well, other sectoral bodies such as rec fishers, NGOs, community groups. The industry can see a huge economic impact at a market campaign that a market campaign would have on them. They're the ones that are going to suffer from the campaign, not the government, so they're moving quicker and more proactively than the government. So you can see that the industry changing its environmental practice, not because of regulation, but because of community pressure. So what I've tried to do briefly, and I've gone over time, of course, is just suggest that extension has a role in many of these spaces where we don't necessarily usually think it does. Traditionally, in this NRM space, yes, it's obvious, and it's most developed there in many ways. But I think increasingly, as we see greater competition for resources, greater interaction of resource users and competition of resource users, we'll see it happening in this space as well, where there's private and public losses, and in these spaces where we use our natural resource base for private gain. So the key points are the same as at the beginning, but the extension enables change when it's integrated with other policy instruments. That scaling extension requires linking science and values to inform societal narratives. So it's broader than just individual people. This is about building the civic capacity to have these discussions effectively and sensibly. And risk, uncertainty and complexity, yes, we can make them useful and usable potentially, but we need to clarify what we know and what we care about. And these seem to be, the care about thing often seems to be the political role, but increasingly I think extension is going to play a role there, whether formally or informally it already is. So that's all I have to say. Well, except I'm willing to answer questions, have discussions. Thank you.
Thanks very much. Hey, very challenging talk. Quite a lot in there.
Yeah, content.
Yes. So, do you have any questions from the floor? Yes.
Thanks, Pete. It's very interesting. The last slide about how public licence is increasingly subject to the use of new media. I'm just wondering whether science and extension, or I guess extension seeing you're really talking, that's the focus of your talk, whether they're seen as being independent enough, because increasingly the social licence for all sorts of industries is the subject of ideology and values, not necessarily science. And in fact, I'd say rarely science. There are groups who will use ideology, who base their media campaigns on ideology and are not interested at all in science. Would you like to comment about that issue of how extension stands in the middle and how it can address these sorts of ideological?
I think it's a good question, Laurie, and a challenging one, because I think one of the fundamentals of science is that you need a clear question that you can address. And when we've got conflicting values, we often don't have those clear questions. And I think what extension can do in being oriented by science, and I take science very broadly as including social research and all sorts of economic analysis, is that it can say, well, what are you actually concerned about? And get people to articulate the values. So when I say articulate, I mean it in both ways, that it's saying something clearly and joining things together. So we can start to see what the constellation of values are, and we can see what we are talking about. So unstructured problems, as I've described them, become more structured because you actually start to see what it is that you're trading off. So we might not be able to provide, you know, a scientific report which answers all the questions, but we can start to unpack the sorts of questions that are values driven that may have a bearing on scientific questions. So it's starting to negotiate the positions, I think.
Just in relation to that question, I was interested in your idea about having some kind of organisation that could represent all those different voices in that ideological space. And could you tell us a bit more about what that would be, how that would work?
So there's a growing literature around boundary organisations, and TIA calls itself a boundary organisation. I'm not so sure Holger calls TIA a boundary organisation. Boundary organisations are effectively accountable to multiple different parties. So one of the case studies that we looked at is a true boundary organisation, and that's the Derwent Estuary Program. It has multiple partners sitting on its governance board, and each of them puts money in, and each of them expects things back. It doesn't actually do research itself, it contracts research out. So it sits between the science and the political decision making, but it doesn't do politics. They do science. But in doing science and getting the people with different stakes to sit around the table and talk about science, they also get them to talk about what they need. So that point I was just making to Laurie. So those sorts of organisations, and the other thing that we found in that particular case of the Derwent Estuary Program is that it allows the people from these different organisations, from local councils and state governments and industry, to develop relationships with each other, which then allow them to have cheap talk in economic terms, which is actually incredibly effective in creating collective action and collective responsibility. So it's a complex picture, but I think those sorts of components, even if they're centred around science, so you don't have the heat in the discussion necessarily, allow for a more diffuse sort of facilitation of change. Sorry, I'm talking a little bit complicated.
on that point then, in terms of boundary organisations, do you feel that, or do you think it's possible that the role of government departments as they used to be, like the Peat Leith and that kind of thing, that are in a way supposed to be answerable to the public, are supposed to be able to be answerable to industry, and now answerable, I suppose, to a minister who's driven by political, what he wants in terms of his political career and his party wants. Do you feel like a boundary organisation and the idea behind it is emerging because of the changing way in which that public relationship with politics and that kind of ability of this disruptive public discourse, I suppose, on the internet and that kind of thing? Do you think that's driving, I suppose, this, trying to drive it back to this answerable to the public thing that's supposed to be going on, where that boundary organisation emerges in order to say, look, we're answerable to everyone. We're not dictated to by government or by this political party. We're dictated to by science and the underlying realities and truths that we are investigating. Do you think that's?
So I think there's a few bits there. Firstly, it's difficult to move the institutional processes of government at the sort of speed that this stuff is moving. And that's partly because, well, there's an Act and the department has obligations under the Act and they're under-resourced to fulfil those obligations. So they effectively try and do their best to fulfil their obligations under the Act. So they're not a nimble organisation. Government is never very nimble in terms of this sort of stuff. So I think what we're starting to see happening is these sort of new institutional forms which are much more nimble but have different people buying into them coming into play, and they're able to just provide the evidence. But I think that the whole thing about getting the different voices around the politics is always going to be difficult with these areas where you've got multiple stakes and multiple things going on. And it's very, I mean, effectively they do come down to politicians at the end of the day to try and manage the mess of voices going on. So I don't know if that answers what you're saying, but it's...
Look, it's been an excellent discussion, but maybe we'll draw to a close there because we can continue discussions outside over a nice cold beer.
That sounds better.
I just think it's been a very stimulating talk. Amazing to see those range of case studies where, you know, the science right down to like those climate dogs. I mean, they're just a great way of getting that nth degree of extension. Are fantastic, and some of these real examples that Tasmania faces in sectors that we all want. You know, it's important for all our futures and our children's futures to make sure some of these industries are on a sustainable footing, so that social licence is really great. So thanks for a stimulating talk. I think I got about a third of the theory stuff, but you're taking me a little bit further down the field. It sort of almost makes me wonder whether we shouldn't at some point get you or challenge the organisations to take a little bit further this societal debate around GMOs, which is, as you say, equally dangerous, and whether there's a need for us at some stage to chair or guide an informed discussion around that. But that's only my view, whether we should do that or not. So thank you. Put your hands together and thank Pete for a fantastic...
Thank you.